Well, thank you, Adam, for the friendly introduction. Today I'm going to present part of the work done by a research group at Carnegie Mellon University, consisting of Teddy Seidenfield, Kevin Zollman, and me. And luckily, we are supported by the Institute D21, so we can do what we're interested in. So thank you for that, and thank you for having me today. What are we interested in? We are interested in comparing different voting methods, including D21, and for doing that, we are using geometry. Well, that might sound a little odd at first. We are following their approach by Donald Sari, who made that theory of voting in geometry like a rigorous theory, but I'm sure you know an example of a geometric interpretation of voting results already. So let me walk you through an example. Well, we have another example of voting for dinner. This time you only have two choices, not Italian and McDonald's. You only can choose between fish and meat. Let's say we are all voting for meat. Well, then we can represent that election outcome by the point to the very right on that line. If we're all going to vote for fish, well, then it's a point to the very left. And if we are equally split between fish and meat, I think you know where I'm going. It's in the middle of that line. Well, that's pretty intuitive, right? We can say everything to the left of that point is going to represent the voting outcomes where we're going to elect fish. Everything to the right is going to represent the election outcomes where we're going for meat for dinner. There is not so much we can do with two options if we want to compare voting methods. So we have to add another option. Let's say we are adding a vegetarian option. Well, note now that we moved from one dimension, from a line, to two dimensions, to a triangle. But also note that the interpretation of our fish-meat line didn't change. Still, if we all agree that we want meat for dinner, the point is still going to be there. If we're still torn between meat and fish, the point is still going to be there. What is going to change now is if a vegetarian joins us. And that vegetarian is going to vote for the vegetarian option. Well, and then our election point is going to move in the vegetarian corner or vertex. And if we're going to have like more people turning vegetarian, that point is going to move up and up to the vegetarian corner. And as we did with the line, we can here identify areas in this triangle which are going to map to the different option wins over another. And what we also can do is directly compare where our point, like where our election outcome is going to land when we are using different voting methods. What we now just implicitly assumed is that we are using plurality vote, one person, one vote. But what would happen if we are using a different voting method? In that kind of framework, we can think of a voting method of kind of assigning different weights to different candidates. We can say if you have one vote, plurality, you're going to put all your weight on your first preferred candidate. Let me walk you through an example. So here, if we are split between meat and fish and we're using plurality, we are going to land in the middle of that line. But we also could use maybe a minus vote, where we can vote against something. And the interesting thing about minus vote, if we are using that weight kind of analogy, to vote against something is the same as voting for everything but one option. So in that case, if you're voting against fish, or if you're voting for meat and vegetarian, it's going to be the same. If we're going to express that in weight option, we can say we put equal weight on every option but the last option. And that, in fact, is going to change our voting outcome. The vegetarian option would win. That makes sense because here in our example, no one loves and no one hates the vegetarian option. So that makes sense. But note that the weights are going to change if we are introducing different candidates. Now we can say with the minus vote, half of the weight goes to the first ranked candidate, half of the weight goes to the second ranked candidate, and 0 weight goes to the least preferred candidate. If we have 3 or 4 or 5 candidates, those weights are going to change. And let me make that clearer by introducing a third voting method. I think we have seen that one before. It's a vote for 2 voting method, and it does exactly what the name suggests. You have 2 votes you can cast. So in that case, it's exactly the same actually as the minus vote. You put half of the weight on the first ranked candidate and half of the weight on the second ranked candidate. But now if we're going to introduce a 4th option, maybe a vegan option, with a vote for 2, those weights are going to remain fixed. Half of the weight goes still to the first and to the second ranked candidate respectively, whereas the minus vote is going to say you hate vegan food. You're going to put 0 weight on the vegan option, but you're now going to put a third of the weight on every other option respectively. And this is going to be translated into the point being pulled in different directions by different strengths in our geometrical figure. Like in the vote for 2, you have half of the strengths like putting in the meat direction, and half of the weight is going to pull the point in the fish option, and with the minus vote, you have then in 3 directions by kind of the strength of a third. You can see that's going to lead to different results, even so if you're going to introduce more options, like 15 options. The vote for 2 weight is going to remain fixed, whereas with the minus vote, it's going to put on the first 14th candidates, respectively, a 14th weight, respectively. And the interesting thing about that now is that often we can express the voting method D21 as a mixture of a voting method which is keeping the weights fixed and a voting method which is changing the weights. That's always the case if we're introducing a minus vote. And there's something we can say about that, but let me simplify it by saying, by putting an example. We are now going to select one option. We have 2 positive votes and 1 minus vote, and I can tell you a little bit more how about that will generalize. So remember, we have the vote for 2, and we have the minus vote. And then we know that D21 is always going to lay on the line between those voting outcomes. So the voting outcome on the vote for 2 and the voting outcome on the minus 2, and D21, the voting outcome, is going to lay in between. What is that saying us? What does it mean? That means it's sometimes easier for us to identify if D21 is going to make a difference. So if vote for 2 is going to elect fish as the dinner option and the minus vote is going to elect fish as well, we already know that D21 is going to elect fish as well. We don't need any more information than that. Let me clarify now. We made a couple of simplifications on the way. So for now, we assume that everyone is going to vote, cast every vote they have. We can make more sophisticated examples, but they're going to be a little bit too complicated to present here. But that is independent that D21 is going to lay on that line of the number of candidates we have, the number of voters we have, or what kind of preferences we have in an election. And we can say even more about where D21 is going to lay, because D21 is also then a voting method which weights are going to change with a number of candidates, just as the minus vote. And we know that D21, the weights, are going to be more and more similar of those of the minus vote with an increasing number of candidates. What does it say us that? Well, it says if with an increasing number of candidates, we can more kind of expect that D21 is going to more often elect the same candidate under a minus vote. And that makes sense if we want a voting method which is pushing consensus rather than just electing whoever the majority isn't if just assume you have 4 candidates, maybe then it's it's very important to you if the first or your second ranked candidate is going to be elected, just like intuitively. But if you have 15 candidates, maybe that difference is not going to make that much of a change anymore, but you really don't want your least preferred candidate to be elected. And that's what this result is going to say, that this D21 is going in, well, is going to respect that kind of intuition. Well, yeah. This is going to, we now set this result for if you have 2 votes, plus votes, and 1 minus vote. We can more examples in different situations where you maybe have 4 positive votes and 2 minus votes, but I can tell you more about that if you have questions about that. Also how it generalizes in other cases, and what we are going to do in the future with this result and where we're going from here. So thank you for your attention, and that's it.